welcome back to Curly Boy Theater, everyone. Our next speaker, Joachim Jablon, is joining us all the way from France, so almost the other side of the world from where I am, if we go all wave down there, where it is early in the morning for him, so thank you very much for joining us. Uh, Joachim is a French Pythonista, software engineer who started engaging with our dear Curly Boy in 2008. He likes working in open source software. He's contributed to bits of the Python package index, among other projects. He has 4 cats that he was telling us about before, which we're very excited to see. What's your cat's name?
Ningishzida.
He has also spoken at and or contributed to organize multiple European Python and Django events. His partner and he lives in the city of Poitiers with the top 4 cutest cats in the world, according to us. And yes, we do want to see pictures. Okay, so Joachim's talk is pre-recorded, everyone. So he will be in the chat answering questions live in Venulus. So don't worry about the questions tab this time. Just talk away, and Joachim will be there with you. Is there anything you'd like to say before we start?
I'm good. We can go. From hat import rabbit. Hacking your way through Python's import machinery for fun and profit. Hi, I'm Joachim and I'd like to perform a magic trick. I have to admit that I'm far too clumsy to be a real illusionist, and my favorite part in a nice magic trick is to explain to everyone how it works, so I'm not a great magician. I've been a member of the Python Packaging Authority since 2020, and both the Python Software Foundation and the Django Software Foundation since 2021, so the paint on my badge is still fresh. Let's dive into it. Let me take you on a short hike where I'll tell you of a trick that I had to perform last year. By the way, we'll be taking the scenic route, so kick back, relax, and enjoy the ride. This magic trick begins with a dove, and as doves migrate to a warmer climate twice a year, so does SQL, which migrates to a warmer schema release after release. In case you're not familiar with what a SQL migration is, let's make a quick reminder. Let's imagine that we're responsible for an application that has user accounts, so it stores usernames and passwords. Now we want to attach some new information to the profiles, such as whether the user gave their consent to store cookies for them or not. This means we'll have to change the database to add a colon in a table, which in turn means that we're going to write some SQL code and run this code on the database. If you're developing a website using Python, chances are you've heard of the Django framework. Because Django helps you with your database, it has a whole subsystem for writing SQL for you, and especially writing SQL migrations for you. And this subsystem is based on Python files that look quite like this. So this is a migration module. So it's a module that contains a single class named migration. And this class inherits Django's own migration class. You can see an attribute named dependencies, where Django puts some things that lets him determine in what order to run the migrations. And the more important part is the operations list, which contains objects such as the add field we can see here, or remove model, or many different objects that Django knows how to transform into migration SQL code. There's still a way we can use the Django migration system if we already have the SQL code by using a run SQL object. So we can provide the SQL code directly, but still wrap it inside the Django migration system. Migrations will be stored in a folder that is aptly named migrations inside each and every Django application. These migrations all live in their own module. And now for something completely different. In the last years, I've been working on an open source project named Procrastinate. Procrastinate is a task queue. Maybe you know Celery, which is one of the most famous Python task queues out there. Procrastinate is kind of the same. Let me explain. In a website, sometimes you want something to be done later. For example, a long task that needs some computation time. And you need to respond to the user quickly. So when they request something that's going to take a long time, instead of doing it synchronously, you just take notice of it and you respond, yep, I'll do that later. That's the name, procrastinate. Of course, you have to then ensure that you will be doing it later. What makes Procrastinate unique, though, is that many task queues such as Celery use RabbitMQ as a broker, but Procrastinate is backed by a PostgreSQL database. PostgreSQL's mascot is an elephant, so one could say that the magic of Procrastinate is turning a rabbit into an elephant. As you imagine, in order for Procrastinate to work, it needs a specific SQL schema, and this schema can sometimes evolve, which means that Procrastinate itself will come with SQL migrations. The Procrastinate SQL migrations are written as pure SQL files, which can quickly become a bit complex. So I'm showing part of a file, I'm not going to explain it, and it's just to give you an idea. The Procrastinate SQL migration files live in a migration folder, which is located within the Procrastinate source code. It looks a bit like the Django migration folder, except that those files are SQL files and not Python modules. So, on the one hand, Procrastinate helps you when you have long tasks in a website, and on the other hand, Django helps you when you're building a website. So quite logically, people may want to use Procrastinate with Django, and for this reason we've built a Django compatibility app within Procrastinate. But you might wonder, what about migrations? The Procrastinate Django application doesn't have a migration module. If it did, it would mean that we would have to manually duplicate the code from the SQL migrations into the Django migrations, and it's something we didn't want to do. What we wanted to do is to make Django believe that for each SQL migration file, as we can see on the left side, there was a corresponding Django migration module on the right in red. But this file wouldn't actually exist on the disk. So we would want to make Django believe that there are modules here, although the migration modules don't exist and the migration folder itself doesn't even exist. So what we wanted were virtual migration files. At first, I tried for quite a while to see if there was such an existing hook for doing this within Django, and it turns out there just isn't. But Python is a dynamic language, so I thought maybe I could take an unofficial way, monkey patch here and there to get my hooks in place, etc. But all I found was this was tricky and error prone, so I didn't like the approach. At the time, a wonderful person of the Python/Django community, namely Marcus Halterman, who was, by the way, on stage yesterday for a talk on authentication, he gave me from the top of his head the idea that I was missing, which was to use the Python import machinery to trick Django. At this time, I only knew that the Python import machinery existed, but I absolutely didn't know what was inside it. So I had to take a route and explore the Python importer secret mechanism, and I'm going to give you some insights from what I learned at the time. So, what's the structure of the import machinery? Let me start by a diagram showing you the interactions between the different parts. Oops, wrong slide. Oh, yeah, that's the one. The import mechanism contains many moving parts, and we're going to introduce just a few elements today. If you find this topic interesting and you want to dive deeper, I will give some pointers to some resources at the end. So let's dive in with the part that you probably already know, which is the import statement. Actually, chances are that you even know multiple forms of the import statement, such as import a.b, from a import b, from dot import a, import a as b, etc., etc. These import statements can actually be translated to assignments and function calls. An import statement always does two things. First, it will import one module using the built-in dunder import function, and then it will assign this module to a variable. By the way, when I say dunder, it's short for double underscore, so you will hear dunder import. It means underscore underscore import underscore underscore. The dunder import function does a few important things. You may know of sys.modules, which is the module cache dictionary. It's a dictionary where Python will store any module that has been imported since the start of the program. Dunder import is both responsible for using this cache to avoid a costly import for modules that have already been imported, and also to add modules to this cache when they have been successfully imported. Second thing, when you import a.b.c, Python will always import a.b first, which in turn will import a. So the parent modules are always imported before the children. And when the import of module c is successful, Python will assign a variable named c into the module a.b. So thanks to that, if you have a module a.b in your code and then you import a.b.c, you'll be able to access a.b.c and get the module c that you have imported. And then the important part is the importing the module itself. So this is a 3 steps operation. First, we'll be looking for a meta pathfinder. A meta pathfinder is an object which, given the import path, says whether or not it's able to find the corresponding module in order to import it. Python keeps a list of meta pathfinder objects in sys.metapath. The idea is that Python will ask every finder from sys.metapath, one after the other, whether they think they can import the path until one says yes. Asking a metapathfinder object is done by calling its findSpec method, passing the path as parameter. The object either returns none if it cannot load the path, or it returns a module spec object. A module spec object is an object that has a few properties describing how to load the module. One of these properties is modulespec.loader, which is a loader object. It has an exec module method, and Python will first create an empty module using the info that it gathered from the module spec, and then it will call the exec module method, passing this empty module as a parameter, and the exec module method is expected to attach attributes to the module, resulting in the final module imported. On normal Python modules that are loaded from a source file on the disk, this would be the part where Python will open the file and then run eval on all the contents, store everything that was created on an object, and attach everything on the module object. So one of the places we'll want to explore in order to add our customization will be the sys.metapath list. Let's first have a look at the metapathfinder that we could find in a classical sys.metapath list. So if you open sys.metapath in a Python interpreter, you'll find the built-in importer and the frozen importer. Those are really low-level finders that Python needs in order to work. By the way, when a class is both implementing the finder interface and the loader interface, we call it an importer. Before going deeper on the next element, let me add a quick note on sys.metapath. So it's just a simple list, and you can actually add your own finders in there. The only requirement is that anything you add in sys.metapath must be a metapath finder. So it must have a findSpec method and must be able to return module spec instances from it. And then there's the main finder that Python implements, which is the one that's used most of the time when you perform an import, namely the path finder. The path finder will look in multiple directories and to see if we can find a module that we're trying to load. For a top-level module, the list of directories to search on the disk is given by sys.path, which is a list of strings. This is the infamous sys.path, otherwise known as Python path, that you may or may not have had to tinker with in the past. Sys.path contains a list of folders on the disk to explore in order to find a module. When the module is not a top-level package, then logically it has a parent, and the parent module has a dunderpath attribute, which is also going to be a list of strings. And similarly, this list of string is the list of places on the disk where one would expect to find submodules of the parent package. So whether you're importing a top-level package or a submodule, you'll end up with a list of folders to explore on the disk. And these folders are called path entries. We're going to iterate on each path entries that we have. The Pathfinder will also use another attribute from the sys module, which is sys.pathhooks. Sys.pathhooks is a list of callables. We will iterate on each callable from sys.pathhook, so we're doing a double iteration both on the path entries and on the pathhooks. So it's just a kind of a two-level for loop. Each pathhook callable receives the path entry as parameter, so the current one in the iteration, and either it raises an import error if it doesn't know how to process it, or it returns a path entry finder. A path entry finder has a findSpec method that may return a module spec. At this point, you may experience a very strange déjà vu. The path entry finder architecture is very close from the metapath finder that we talked about before. And you may think that we're stuck in an infinite loop of meta path entry pathfinder going forever. So I'll do my best to make it explicit what the difference is between a path entry finder and a metapath finder. Metapath finder tells you whether or not it can find the module a.b. A path entry finder tells you whether or not you can find the module a.b inside one very specific folder on the disk, which is the path entry that the pathhook was called with. So path entry finders are very specialized metapath finders that restrict themselves to searching on the disk inside one single directory. So, as I said, in order to determine if the path entry finder manages to find your module, we'll call findSpec, the findSpec method with the path attribute. So kind of same as for the metapath finder. So same as for the metapath finder, either it returns none, and then we would go on and try another path hook or another path entry, or it returns a module spec, and hooray, we found our module. So, what would be the default path hooks provided by Python? The first one is a zip importer path hook. So it's the one that lets you run Python modules that are inside zip files. By the way, yes, you don't have to unzip archives to run Python files that are inside zip archives. One of the hooks, the second one, is a file finder. So it will look for classical Python files and folders on the disk, such as .py files, .pyc files, .so files for compiled modules, and as well as folders containing dunderinit.py, etc. And then you can add your own callables to the path hook. So one way to do that would be to implement your path entry finder class, and you would give it a constructor, dunderinit, that receives the path entry. So you'd register the class itself as the path hook. Python will call the constructor and pass the path entry as parameter, so you may store this as an instance attribute. And then Python will end up with a path entry finder, your path entry finder instance, and it will call the findSpec method on it. And so this way you'll be able to access both the path entry and the import path that's being searched. So we're approaching the end of this incursion into the wonderful land of Python imports. If we remind ourselves of the initial goal, we were looking for ways to trick Django into believing that there is a migration folder and that this folder contains plenty of migration files. So Django is going to dynamically import our application's migrations module, but because Django doesn't know in advance the name of our application, it would be complicated to use an import statement directly, because the name of the thing to import will be inside a variable. Django could use the dunderimport function directly, and it would work. But this function is made for Python to call, and there's actually a better interface for programmers to use, which is the importlib module. This function's goal is to import modules when the path is dynamic. So import module actually calls import under the hood. So Django will call import module and will expect to receive the migrations module. One thing you might be wondering is, now that Django has the migration module, how is it able to discover all the migration submodules that exist inside the migrations module? So for now, we've talked about how to import a module given its name, but not how to browse existing modules. This is something we can achieve with pkgutil.itermodules, which receives the module path and returns a list of objects that reference the name of the submodules below that path. So it taps directly into the pathfinder and the path entry finder interfaces, and in particular, it will call a method that's named itermodules on all the path entry finders that we found. Then Django will know the existing name of the migration submodules, and it will call import module again on every submodule that was found. So it will read and hopefully use the migrations. So if you want to take a screenshot of the graph, this might be the right time. So, what does it look like in Procrastinate? Let's have a look at the code and see the magic trick for real. As a reminder, we're trying to generate both the migration module, the dunderinit.py, and the individual submodules for each migration. Also, here's what a migration submodule looks like. It contains a single class named migration that has a few attributes. So, creating all the migration classes dynamically by inspecting the existing SQL migrations is not the hardest part of the problem. Here's a simplified version of the code. It's a function that takes a migration written in SQL as a string and generates a Django migration class. So this will be the class we want to attach inside the virtual dedicated migration module that we're creating. In order to tap into the import machinery, we'll need to create an importer, which, as you remember, is both a metapath finder and a loader. You can see that in the inheritance of this class. In the constructor, we'll generate and then store all the migration class that we're going to want to dispatch into our virtual modules. Our importer is a finder, so it needs a find_spec method that will only work for the migration module and the migration submodules. If we receive the right path as parameter, then we will return a module spec instance, and otherwise we will return none. On our module spec, the loader is set to self because this instance is both the finder and the loader, so the loading part will be on the same object. Then let's look at the loading part. We receive an empty module as argument, and our job is to attach things to this module. The loader must be able to load both the migrations module and the individual submodules. If we are loading the migrations module itself, then the only important thing is the dunderPath attribute, because the string we add in there is the one that will later be checked by our path hook. We want to make sure to put something that will not be recognized as a valid path by other hooks, thus using angle brackets, as you can see here, which is unlikely to be a path on the disk. If we're using a submodule, that's the moment where we finally get to do the magic. We figure out the name of the module we're building using module.dunderName, and then we attach the class, the proper class, inside the module. Now, our importer will also have methods that will be added to sys.pathHooks. So let's see how it looks like, what it looks like. So this is the method that you can see above. It only reacts to paths that match the dunderPath attribute that we've set on the migration module. And it returns self as the loader, the finder for any path that matches our virtual path, and it raises an import error for anything else. What you can see below is the implementation for the iter modules method that allows Python to list all the submodules that a module contains. In here, you can see that we are leveraging that we've already pre-computed all the migrations and stored them in the finder and the importer class. And then the last touch, we register our importer in sys.metapath and the pathHook method in sys.pathHook. Note that we're being good citizens here. We're adding our stuff at the end of both iterables, which means that our strange importer will be called, but only if the other conventional import mechanism didn't succeed. In other words, we are not slowing every import down, but we're just slowing a little bit the unsuccessful imports. So showtime. Now it's time to ask Django to apply our migrations, and everything kicks in from all over the place. So Django will try to find the migrations module, it will find it, and then it will explore all the sub-migrations. It will, the sub-modules, it will find them, and then execute them, and everything runs smoothly. Presto! Phew, what a journey! I hope you're still with me. Before leaving the stage, let me share a couple of thoughts. First, yes, this might be an over-engineered solution, especially given we could have a static migration generator that would write normal Python files, but in all honesty, I'm infinitely happier that I got to learn a ton of stuff doing this and to share it with you folks. And to this day, I still feel that hooking the import machinery is definitely the cleanest solution to the problem we had. Also, it doesn't really add a lot of complicated code in the end. If you plan to use this knowledge to do some good, you should definitely play with it and make it into a nice library. If you do so, please feel free to send it my way. But remember, smart code goes into libraries and boring code goes into projects, because no one wants to debug a very custom meta Python tree pathfinder that went wild into production. And even for procrastinate, I still think it might be a good idea someday to refactor the custom Django migration process into a dedicated library. And finally, the import machinery is a very interesting part of Python, and it could give birth to very innovative uses. Knowledge of this might not change your day-to-day practice, but it can be one or more tool in your belt. And as a general advice, Python is a very accessible language, and it's often both quite rewarding and useful to take some time to learn how one specific Python subsystem works. And so, yeah, be curious with language and experiment and do some magic. Thank you. I'll be glad to take some questions, but while this is a pre-recorded video, the live questions session will be featuring a live version of me, just woken up at 6 a.m, so please be gentle. Thank you very much, Gulwen, also known as Nautil Bleu, for the illustration, and have an excellent day, and see you around.